Okay, 4, 3, 2, 1. Here we are. So all we want to do today is just reintroduce the fundamental theorem of calculus part 2. I just want to show you a couple of tricks of the trade of some things that are maybe a little bit more challenging. Everybody agree if you look at letter G, you say, well, that looks a little bit tougher. So we need to be able to handle those type of expressions as well. And so what I'm going to do is I'm going to start by simply rewriting this expression as the integral from 1 to 2 of 1 over the root of x minus the cubed root of x over the square root of x dx. Is everybody okay with that? So you can take a fraction and break it up into two parts. Just break each piece up over the denominator. So now I have the integral from 1 to 2 of 1 over x to the 1/2 minus x to the 1/3 over x to the 1/2 dx. And what's the antiderivative of 1 over x to the 1/2? Let's see what Aiden did there. He sees that 1 over x to the 1/2 is x to the negative 1/2.
Negative 2x.
So we'll do that in a second, okay?
So we're rewriting.
So I'm going to find this antiderivative as Aiden did, but as people didn't see it right away, I'm going to make it a negative 1/2. And then x to the 1/3 over x to the 1/2. Anybody? X to the negative 1/6. We simply subtract those exponents. So now we'll take that antiderivative as Aiden said. He said that will be x to the 1/2 or the square root of x divided by 1/2 or multiplied by 2. So I have 2 roots of x minus x to the 5/6 divided by 5/6 or multiplied by 6/5. And I would evaluate that at both 2 and 1. Can we skip the evaluation part and trust that you guys can plug that in and do that?
Yeah.
Okay, so you just come up with a decimal in that situation. No big deal. We move to letter H. Integral from -1 to negative 3 to -1, 4y minus 3 over y squared dy. So I'll write this as 4y minus 3y to the -2. The antiderivative of 4y, 2y squared. The antiderivative of -3y to the -2.
3y.
Why is it 3 over y?
Because they're 2.
And this is one that we can evaluate pretty easily by hand. And so I'm going to plug in the -1, and I get 2 times 1 is 2. I plug in the -1, and I get -3. I plug in the -3, and I get -3 squared is 9 times 2 is 18. I plug in the -3 here, and I get a -1. That works out quite nicely. I get a -1 minus 17, which is -18. What does that mean, the fact that the area came out negative?
It's below the x-axis.
Simply sits below the x-axis. Okay? It's fake. Talk to the person next to you. What's your first inkling for letter I? What would you do? First inkling for letter I. Talk.
No, it has to be squared. That's what I thought. like this. Sine to different fractions. One over secant. Yeah, so 1 over secant.
What?
Am I genius? Okay.
Thought? You have a thought? What would you like to do?
Is 1 plus tangent.
Cosine plus tangent.
1 plus tangent squared is secant squared, so that substitution will not work. Okay, in this scenario, 1 plus tangent squared is secant squared, but we don't have a secant squared, and we don't have a tangent squared, do we? And so in this situation, the best option is to rewrite it as such, is to go 0 to pi over 4, we'll see if you did this, of 1 over secant plus tangent over secant. Split it up into 2 parts. Because what is 1 divided by secant? Cosine. And we know the antiderivative of cosine, don't we? So we have 0 pi over 4 of cosine of theta plus tangent divided by secant. How do you do that? Good. Sine over cosine. Divided by 1 over cosine. Cosines cancel, leaving you with? Sine. Well, that's pretty nice, isn't it? What?
What if we don't write the d of theta?
Not d of theta, just d theta. And if you don't write it, I tend to look the other way on the test. I remember my last Calculus 1 test, and I had 98 out of 100 on the test. And I asked the professor, I said, I don't see my mistake. I thought I got everyone right. He's like, you did get every problem right. I said, where are my 2 points off? He said, you didn't write the d theta.
So I'm supposed to write it?
You're definitely supposed to, without a doubt. It's mathematically incorrect to not write it. Am I going to dock that? Not necessarily, but
Okay.
I want to try to set you guys up for success moving forward. So, but maybe your teachers won't be like mine. Maybe I don't know.
Okay.
Your teachers might just hand out A's. Some colleges do that.
Oh, can I go to
What
those
college
colleges?
is that?
I will keep that to myself. So the antiderivative of cosine is sine of theta. Is it sine or negative sine? Sine. What's the antiderivative of sine? Negative cosine. We evaluate pi over 4 and at 0. What's the sine of pi over 4?
I have a question for
Oh,
you.
root of 2.
Yeah?
Does it matter what side we put that line on? Because you've been putting it on both sides, and I get a little confused. Is it the same thing?
So just to be clear, this is a bar and it's used to evaluate. I always put the numbers on the right-hand side. This is the integral sign, which is different than the bar. I always put the numbers on the left-hand side.
No, I mean,
Right
like,
up
you
there.
have sine minus cosine, blah, 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 then the line. But sometimes you do the line, then blah, 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 blah.
Never. Never
Why
done
is
it.
the line on the back side now?
I've never done that. I've never put the line on the front.
You're evaluating, not integraling.
This is an integral. This is a bar. These are not the same things.
I'm aware, but I don't understand why it, never mind.
It always goes to the right side. I don't think I've ever put it on the left side. Yes.
Okay, but the integral, you're at the top, it's on the right side.
It doesn't matter.
Very top. No, very, yeah.
That's the way that it's just the way the computer prints it out.
So
It doesn't really matter. I tend to always write, the idea is you put one at the bottom, one at the top.
so the integral, it doesn't matter. The
Nope.
bar does.
It really doesn't matter. It doesn't. So, no, you're fine wherever you want to put it. I tend to put it on that side. What's the sine of pi over 4? Root 2 over 2 minus root 2 over 2 minus, now we do 0. Sine of 0? 0. Minus 1. And so what do you get? 1. Is that nice?
What the heck? Can you go up? Yeah, that part.
Sine of pi over 4?
Yeah.
Root 2 over 2?
You got that right, 50%. I have to drive around everything.
So you got a 45-degree angle?
I know it's that point is, you're just finding the sine and the cosine.
Yep.
Oh, okay.
Better?
Yeah.
Okay. All right. All right, last example. We'll see if you can get this one. Talk to the person next to you. What would you do for letter J? What would you do for letter J? Think about how you'd start this.
So it'd be, then could you do 1 over tangent times sine over 1 and then cosine over sine? Oh, see, silly me. Okay.
Isn't it
Times sine theta.
number?
And then you just see, look at,
Okay, I heard you guys talking and you thought correctly. Here you do have cosine over sine times sine over 1. And notice that your sines do in fact cancel. So this is simply just the integral of pi over 6 to pi over 3 of cosine of theta d theta. Looks like a complicated problem. A lot of people see the cotangent and they shut down.
I'm shutting down.
So cotangent is cosine over sine?
Uh-huh, that's what I'm shutting.
Wait, what?
Did you flip it and then you make it?
So cotangent is cosine over sine?
Isn't it 1 over tangent?
Yeah, but then tangent is sine over
Yes.
cosine, so you multiply by
But-
And then you have to flip it.
Yeah, and you could write it as 1 over tangent, but that doesn't really help us simplify anything. So I take the antiderivative cosine, which is sine of theta, and I evaluate that. I don't use an integral sign, I use a bar.
I understand.
Pi over 3 and pi over 6. And I plug in pi over 3. What is the sine of pi over 3?
Root of 3 over 2.
Good, root of 3 over 2. And what is the sine of pi over 6? 1 half. And I get the root of 3 minus 1 all over 2 in its glory. There it is. Not too shabby, huh? Just think how tough this class would be if you weren't so smart. Unfortunately, you're geniuses. You've got like a half an hour to work. On your mark and set, go. We were missing ZZ today. ZZ, shout out. We miss you. Taylor, move seats since you weren't here. She's in tears.
No, she actually just thinks we're cooler.
Taylor, you want to give her a shout
I
out?
didn't say that. Hi, Blizz Dog.
Wow, Glizz Dog. That's what we're going with. Very good.